In this video we're going to talk about two important concepts or quantities for this subtopic, and they are magnetic flux and magnetic flux linkage. Now, magnetic flux is given by the Greek capital letter phi, and magnetic flux is defined as phi equals B, the magnetic field strength, times A, the area cut by the magnetic field, times by the cosine of the angle between the normal to the plane of the area and the direction of the B field. So here we have an area, cross-sectional area A, which is being through which the magnetic field is going through. So I'm trying to draw this in three dimensions. We might have a magnetic field going now not perpendicularly, but it's going at an angle, and it's going through the plane, so it's going above and below. Now you see it's not going perpendicular to the plane, so I have to draw a normal to this plane, which is at 90 degrees, and you see there's an angle here. The angle theta is the angle between the normal, let's label this as the normal, and this green here is the magnetic field. So there's some deductions we can make from this. Phi is going to be largest when the angle is 0, because then cosine of 0 is 1, i.e. when we have the magnetic field perpendicular to the plane. And phi is going to be a minimum when the angle is 90 degrees. In fact, there will be no magnetic flux. It's when we have the magnetic field in the same plane as the plane of the coil. In this case, this is a coil of wire. So magnetic flux linkage and magnetic flux are related. Magnetic flux linkage, I don't know if there's actually a symbol for it. Is equal to the number of turns of the coil times by the magnetic flux phi. So it will just be N times B times A cosine theta. So therefore, instead of just having one coil, we would have one coil, two coils, three coils, and so on. And then we'd have being cut by a magnetic field. B. And we're going to come back to these. These quantities are important when we come to talk about Faraday's law and induced EMF.